Hello, let's continue our Sudoku adventure with more Chaos by Strosahl. So this continues our Chaos Construction theme week. Hope you're enjoying it. We have this puzzle and then one more, and then the week's over. So hope you are enjoying that. So let's go over the rules. We do have standard Chaos Construction rules. And so in every row and every column, we are placing the digits 1 to 6 exactly once each. We also have 6 hidden regions in the grid, each containing 6 cells, non-overlapping. And so every cell will be part of a region. And in these hidden regions, we're also placing the digits 1 to 6 exactly once each. Now, the regions have to be fully connected by edges. So they cannot be connected diagonally. So these are technically connected by the diagonal, but they have to be connected by edges to count for a region. So we can't do something like this. We can't do something like this. We also can't do something like this, even though these are connected and these are connected. We're not fully connected. These are not, this blob is not connected to this blob. So a region can be something like this, for example. That would be fine. And so, yeah, we need to find all 6 regions, but they are not given to us. That's part of the puzzle, is to find the regions. All right, we also have clues outside the grid. These are called X-sum clues. And so the way these work, let's take this 12, for example. I'm just checking my capture. Yeah, okay, all the numbers show up. Okay, good. So this 12, for example, whatever digit goes here, let's say we put a 4 here, then what that tells us is that the first, that means n equals 4, and that's important for this. The first 4 digits, including itself, are going to sum to 12. In addition to that, these 4 will be part of the same region, and then we must have a region border after it. So there has to be a different region after it. So that's going to help us define our regions. And so whatever this digit is, those digits sum to the clue outside. And then that same number of digits are all in the same region. And then we must have a region border right after. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. Which X sum do we want to start with, I guess is the question. Now, these question marks are just going to help us define regions based on the number there. We don't know the sum. 6 is pretty low. So you can never put 1 as an X sum unless the sum is 1, because that would mean only one cell is used. If we put a 2 here, then in 2 we can add to 6 using a 4. And if we put a 3 here, then we could do 1, 2, 3. Now, I'm not going to put 1, 2 here, but this is definitely 1, 2, or 4. And so these 2 are part of the same region for sure. We'll make that the green region. And then there's a border either right after this or here. Now, one property that I haven't used since I think the first puzzle is, let's say we did have a border here, right? And then this was a purple region. And we decided to put another border there. Could this be green again? And the answer is no, because we can't get this green over to this green and still have purple allowed to have 6 cells, because green would completely surround purple. And in order to completely surround purple, with purple being at least 6 cells long, green would have to be giant. It's just not going to work. So the conclusion we can make is that this is definitely not green, because either this is a 2, in which case this is purple and then this can't be green, or it's a 3 and there's a border there. And so we can call this a purple region. And it's going to be, let's see, for 14, if we count 6, 5, 4, that is 3 cells, and that adds to 15. But the problem is it doesn't involve the 3, right? If I wanted to do like 6, 6, 5, 4, 6, 5, 4, I could do 3, 5, 6, right? If this was a 3, then I just need 11 more and we can do 5, 6. So this is one way this could go. So this could be a 3. If it was a 4, we would need 3 digits that add to 10, which is definitely viable, right? 3 added digits adding to 10, we could do 2, 3, 5, for example. There's a few other ways to do it. So 4 is fine. 5, though, 5 digits, even if you make them as small as possible, add to at least 15. So this is 3 or 4, which means at least these 3 are the same region. Now, can we do the same logic of this one not being purple? So if this was a 3 and this ended up, say, blue, could this be purple again? And in this case, let's see, 1, 2, 3, 4, 5, 6. No, we would need 7 to go around blue to get to it. So we can call this blue, because it's definitely not green. It's not going to reach green. And purple can't reach it either, because it'd have to go around this cell, and that's too many. Okay. I don't know if making that blue is helpful, but... So if this is a 3, this ends up a 4. That's something to keep in mind. If this ends up a 3, this ends up a 2. What else can we think about? Maybe this 8. So it's not a 1. If it was 2, this would be 6. So again, we know these are the same region as each other. I think I'm going to get rid of this blue, even though we know it's a different region than purple and green, because I want to make this orange. So if it's a 2, we can have a 6. If it's a 3, then we need these two to add to 5, which is perfectly reasonable. This could be 1, 2, 3, or 4. Couldn't be 3. It could be 1, 2, or 4 to add to 5. 3 is used. So okay, yeah, we're not doing a 2-3 pair with a 3. So we're doing a 1-4 pair with the 3, right? 4 is too many. 4 cells add to at least 10. 1, 2, 3, 4 is 10. So again, this is a different region than orange. I think. Maybe. One thing we can say is, so 12 plus 8 is 20. So that means that the sum of the x sums for 12 and the sum of the x sums for 8 are going to add to 20 in total. And 20 must use 5 cells, and we have to omit the 1. Because the entire row adds to 21, which means there's 1 cell in between the 2 x sums that adds to 1, because these two add to 12, which means we can't use the 1 as part of our 8 sum. So we can't do 8 and 3, because 8 and 3 always requires 1. It would be 3, 1, 4, in fact. But we can't use the 1 as part of the orange, because the 1 needs to be outside of the 8 and the 12 sum, because 8 plus 12 is 20. In order to get to 21, we need 1 cell that isn't part of those 2 clues that is a 1. So because this can't be a 1, this does end up being 2 and 6, and we get our first actual digit. There's a border there. And now that border has to be where the 1 goes, because otherwise the 1 would be part of our 12. So our 12 has to be a 3. And then this is going to be 5, 6. Oops, sorry, not 5, 6. Sorry, 3, we need 9. This is 4, 5, right? I got confused. So these are red, because we know they're not orange, because orange can't come around and take all of these. That's just not viable. There's too many cells. And purple can't take all 3 of these, and green certainly can't get up here. So there is going to be a border there. This could be purple, so we don't give it a color yet. Oh no, we know it can't be purple. Can it? Yeah, because purple has a border. Purple has a border here. Actually, we can just get some digits, and that might help a little bit. A little bit. So this is 2, 4. Oh yeah, okay. That 2, 4 does give us this 3. So we have a border here, and we have a border here. I hadn't noticed that if this was 2, that does force this to be 3, and if this is 3, it forces this to be 4. Anyway, this 4 comes up giving us 5 and 4. All right. So this has to be a new color, because we cannot be orange or red, or otherwise we wouldn't have a border, and purple can't get to it, because it actually has no path to it at all, because this has to be a different. So I can give this yellow. Now this could be red, right? It could be orange. So we can't actually give this a color yet, but we know that this is not red or orange. It's not purple, and it's not green. So it is actually yellow there. All right, we have this 10 clue, and this 6 is sitting here. So if this was a 2, that doesn't work, obviously. But we can't make this 4, because in order to do 10 and 4, you have to do 1, 2, 3, 4, and there's a 6 sitting there. So this is definitely a 3. So these are all orange. And then there's a border here. And this needs to be a 1 to add to 10. 6 plus 1 plus 3. All right, so this would be isolated unless it was orange. And so it's not 1, 2, 3, it's only 4, 5. It's not 6. Okay, so to get to 14, so we need 11 more in these 2 cells. So this has to be 5, 6, and we know the order. I think I had said that earlier when this was a 3. See, this could be a 1. The question mark clue could be a 1, and we'd have a border there. But if we did that, what region is it? Right? It can't be its own unique region, like not any of our existing colors, because it can only take 4 cells in that case. But we know it's not yellow, because yellow already has a 1. I mean, it's not orange, because orange already has a 1. So this is not a 1, which means it has to be red. and this is not 3, 4, 5. So this is 2 by Sudoku. This is 1, 2, or 6, but 6 doesn't work because that would mean these are all the same region, and that definitely doesn't work. In fact, yeah. So 1 or 2. So this is not a 1 because we don't have a border there. So that we just said it wasn't 1. So this is a 2, and there's a border right there. Okay. Getting there. Let's see, anything forced? Yellow is a bit forced because even if it took these two, it doesn't have to, but even if it did, it would only have 3 cells. So this would be 4 cells, still could only grow to here. This would be 5 cells. So we know there's a border here, and we know there's a border here because we can't share the 1. We can have 2 1s in the region, I mean. How about this cell? Ah, right. So could this be 1? I guess is an important question. I think not. So if this was a 1, there would be a border here. And now, what region is 1 in? Like, how does it get all its cells? I guess it could take 1, 2, 3, 4, 5, 6, and then that could be purple. Darn, I think that works. I thought it was trapped with not enough. So I think we can do that. So this could be 1. It can't be 2. It could be 3. It cannot be 3, because if it was 3, now it's purple, and purple already has a 3. If it was 4, that actually, let's see, 1, 2, 3, 4, 5, 6. That would make purple this. And there's a problem with that, because now these cells can't be in any region, because purple's done, and this is only 4. So it's not going to be 4, and it can't be 5 or 6. So this actually is a 1. So it is the scenario that I said, which is this is a new region. Wait, is there a reason it can't be purple? Yeah, it can't really reach purple because it has to go around. It can't take this cell. 1, 2, 3, 4, 5, 6. It can technically reach purple, but then what does this cell do? Right? It would be a region of size 1. So, and if we can't even give it enough room. So, yeah, if this is purple, this is non-purple, and it only has 5 cells to grow into. That's the easiest proof. Okay, so this is not purple, and it's not orange because it's a 1. So this is actually our yellow. Sorry, this is blue. This is our last region, and it has to take exactly these cells in order to grow to 6. Which means this is purple, and there's a border here. There's borders here. Orange now can only grow in one way. Now it's done. Red takes its standard Sudoku box. Okay. We don't have any new regions. We have all of our regions. And so we can't make a new region out of this cell. And it's not green because there's a border there. And it's not yellow because the only way yellow gets down there is a straight shot. And now purple only has 4. So this has to be purple. Okay, this is 4. This is a 4 and this is a 5. Just doing Sudoku. This is a 2. Here we need a 1 and a 6. This 6 tells us the order conveniently. This 5 and 2 end up down here, and this 2 tells us the order, right? Because 5 and 2 aren't here, so they have to be in these two, because this blue region needs a 5 and a 2, and this 2 says 2's there, 5's there. So these remaining digits are 3, 4, 6. This cannot be 3 or 4, so that's our 6. Left with the 3, 4 pair. This cell's a 1 to finish the row. This column finishes with a 4. So now we have 1, 3, 4, 5, 6. We need a 2. So it's going to grab a 2 from one of these 2 cells. Oh, it can't grab it from here. So it has to grab its 2 right from there. And now purple is done. Yellow now has to continue. What's the rest of this row? We need 3, 4, 5, 6. This is not 4, 5. This is not 4, 6. That's not 3, 6. Okay, there's only one more 1 in the grid to place. Let's place it, and it's going to be green. Right, it goes here, and it has to be green, because green needs a 1, so it needs that last one. What about 3s? So, I'm not entirely sure about 3s. 4s? Okay, let's skip 4 as well. 5s. Okay, yellow needs a 5, green needs a 5. So 5 in one of these two. So 5s are in this pattern. Well, green obviously takes this cell. Let's do that. This is 3, 5. This is a 6. Sorry, this is a 3 because it can't be 6. So that's 3. Yeah, finish the row. That's 6. So green has to take this 6 because yellow already has 1. So then green, then this cell has to be green, and now green is done. There we go. Okay. So now yellow has that 3, so this is 5, 4, this is 3, this is 5. We get 4 and 3, and we're done. All right. Oh, I forgot to do the border. Let's do that now, just so it looks nice. All right. Cool. Neat puzzle, Strosahl. I really like the concept. We actually had 2 XSum puzzles in a row, but the previous one was internal XSums. I like how this question mark ended up the 1. I tried very hard to prove it couldn't be 1, and then ended up proving it could only be 1, which was really interesting. I like the use of the question mark clues to kind of define some of the regions. Like this one being a 1 would have given that away. So it's neat that you can make it a question mark. Cool. Well, I really enjoyed that. Especially liked thinking about this row where 8 plus 12 is 20. So we needed a 1 not part of those clues in between them, which forced them, which was really interesting. So cool. Hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.